What was the ocean's version of T-Rex? Was it a mosasaur, megalodon, or some other massive reptile with jaws full of teeth? Maybe. But what if it was an octopus? An animal with almost no bones to leave behind. Just a soft body that the ocean could erase almost completely. Because the Cretaceous ocean we usually imagine is built from the things that survived. Skulls, teeth, shells, and skeletons. But if a predator was made of muscle, skin, nerves, and water, the story becomes harder to see. You would have to look for something smaller, something tougher, something almost too easy to miss, and then ask whether one black curved beak could change the way we imagine an entire ancient sea or not. The beaks came from Late Cretaceous marine rocks in Japan and Vancouver Island. At first glance, that does not sound like enough to rebuild an animal. But for cephalopods, a beak can be one of the only pieces that survives. Octopuses and the squid do not leave fossil bodies the way reptiles do. Most of the animal is soft except the beak. It is tough, dark, curved, and made from chitin. So under the right conditions, it can stay behind after everything else is gone. That is why old papers mattered. They showed that these rocks were preserved large coleoid jaws from soft-bodied animals that were otherwise almost invisible. The fossils were not complete animals, but they were not random scraps either. They were the feeding tools of something large. One jaw, later assigned to Nanaimoteuthis haggarti, had a lower jaw length of 86.4 millimeters. For comparison, the largest giant squid has a lower beak length around 57 millimeters, so this fossil beak was far bigger than the beak of an animal we already think of as enormous. The problem was that size alone did not tell researchers exactly what kind of cephalopod it came from. Earlier work leaned toward a vampire squid-like animal, which made sense with comparisons available at the time. When the only solid evidence is a beak, the animal you compare it to can change the whole reconstruction. That is where the 2026 paper shifted the story. The beak was not just larger than expected, it may have belonged to the wrong kind of animal entirely. In 2026, researchers looked again at the jaw shape, the cutting edge, the muscle attachment areas, and the wear on the fossils. Their conclusion was that the older vampire squid comparison did not fit as well as an octopus comparison. More specifically, they argued that these were giant finned octopuses, related to serrate octopods. That is strange because modern serrate octopuses are not animals people usually imagine as sea monsters. The living relatives include deep-sea forms like Dumbo octopuses with soft bodies, webbed arms, and small fins. But a fossil relative does not have to say the size of its modern cousins. When the team estimated body size from the jaw, the answer depended on which living serrate octopus they used as the model. Compared with Ceratothus muelleri and Nanaimoteuthis haggarti, came out around 1.6 meters in mantle length and about 6.6 meters in total length. That alone would make it larger than any octopus. Then they tried another comparison, Startoothus sartensis. With that model, the animal became much larger, about 4.4 meters in mantle length and about 18.6 meters in total length. That is the number that gets attention, but it is also the number that needs the most caution. We do not have the body, we do not have the arms, the mantle, or the fins. The estimate comes from jaws, and jaw-to-body scaling can shift a lot depending on the reference animal. Some experts have said exactly that in public coverage. Kirsten Kluck called the near 19 meters estimate extreme, and other researchers have been careful about treating the upper number as settled. So the clean version is this. Even the lower estimate gives us the largest known octopus. The upper estimate, if it is right, turns Nanaimoteuthis into one of the most extreme invertebrate predators ever proposed. Either way, the beak is enough to make the old Cretaceous ocean feel less simple. The other reason this story feels different is the way some of the fossils were found. Not every jaw came from someone splitting a rock and seeing a fossil on the surface. 12 of these specimens in the 2026 study were found through digital fossil mining. The team used rocks from Yezu Group in Hokkaido, marine sediments from roughly 86 to 72 million years ago. They ground the rock down in a very thin layers and photographed each new surface. Each photograph was a slice through the inside of the rock. After enough slices, hidden fossils could be reconstructed from the image data. Machine learning tools helped recognize cephalopod jaw shapes that would have been easy to miss by ordinary collecting. That matters because it explains how an animal this important can stay hidden. A bone can wither out and catch your eye, a tooth can sit loose in sediment, a shell can split cleanly across a slab, but a small black beak inside dark rock might never announce itself. You may only find it by taking the rock apart layer by layer. So the fossil record was not telling us clearly that giant octopuses were absent. It was just not showing them to us. Digital fossil mining does not mean AI replaced paleontologists. The work still depends on sampling, preparation, imaging, anatomy, and interpretation. But it does open a new way to search for animals that were almost built to disappear. The beak also says something about feeding. In the 2026, the larger adult jaws showed heavy wear. The cutting areas were damaged in a way that fits repeated use against hard prey. Younger specimens were smoother, while older and larger ones carried more damage. That is a useful clue, because a beak is the part of the animal that actually meets the prey. If it is chipped and worn, the animal was probably not living on soft food alone. The exact prey is still uncertain. We do not have a perfect last meal preserved from Nanaimoteuthis, but hard prey in that ocean could have included shelled cephalopods, crustaceans, and possibly vertebrate remains. So the important claim is not that we know every animal it ate. The important claim is that it looks like a large octopus capable of handling resistant prey. That changes its whole role. At the lower estimate, it is already a major predator. At the upper estimates, it becomes something that could sit in the same ecological conversation as the famous marine reptiles. Not because we have proof it fought mosasaurs, we do not. Because a soft-bodied animal known mostly from beaks may have been large enough and well-equipped enough to matter near the top of the food web. This is why the Cretaceous ocean can look more reptilian than it really was. Marine reptiles left strong fossils, sharks left teeth, ammonitoids left shells. These are easy to find, count, and turn into a story. But soft-bodied animals did not fossilize easily. They could be common, active, even dangerous, and still almost disappear from the record. That is what makes Nanaimoteuthis important. It was not just a big animal. It shows how a predator could matter in life, but vanish after death. Without its beak, and without digital fossil mining, we might never know it was there. So yes, the Cretaceous was an age of reptiles, but that does not mean reptiles were the whole story. The ocean was full of food web, fish, sharks, ammonitoids, reptiles, crustaceans, and soft-bodied cephalopods. And some of these cephalopods were not background animals. They were big enough to matter. A giant Cretaceous octopus is easy to imagine. You picture a mosasaur turning toward it. The octopus spreads its arms, teeth meet suckers in dark water. It's a powerful scene, but the fossils do not prove that. There is no preserved fight between a mosasaur and Nanaimoteuthis. No stomach content, no direct evidence of the battle. So if we show it, it has to be clear. This is reconstruction, not proof. Modern animals can help us imagine it, but only carefully. Sperm whales ate giant squid, and squid beaks and scars show these encounters can be violent. But that does not mean the same thing happened in the Cretaceous. The more important point is simpler. An octopus is not a reptile, it is not a shark, it is a different kind of predator. Modern octopuses have nervous systems spread through their body. Their arms can sense, grab, and react with a lot of local control. That does not mean each arm has its own brain. It means the animal interacts with the world through touch in a way vertebrates do not. If Nanaimoteuthis had even part of that ability, then size was only part of the danger. It may have been a large predator with arms that could explore, hold, and control prey while the beak cut and crushed. And that is enough. The real animal does not need a fake monster fight to be interesting. The known fossils of Nanaimoteuthis came from Late Cretaceous, around 86 to 72 million years ago. That matters because the asteroid impact happened later, around 66 million years ago. So this is not a simple story, the asteroid wipes it out. Maybe these octopuses disappeared earlier, maybe the environment changed, maybe their prey changed, maybe later fossils just have not been found, or maybe their jaws stopped preserving in the rocks we have studies. For a soft-bodied animal, silence in the fossil record is hard to read. It does not give us a death scene. It only tells us where the evidence stops. And for an animal that was already almost invisible, that kind of ending makes sense. The best version of this story is not that a 19-meter octopus definitely ruled the Cretaceous ocean. That is the easy version, and it is too confident. The stronger version is this. One curved beak forces a better question. What else are we missing because it did not fossilize like a reptile? Nanaimoteuthis haggarti may have been about 6.6 meters long. Under the largest estimate, it may have reached 18.6 meters. That range is wide because the body is gone. But the jaws are real, the wear is real, the digital fossil mining is real, and the implication is hard to ignore. The Cretaceous ocean was not only shaped by animals with skeletons. Some predators disappeared after death. Some left only small black tools in stone. Some were missed because we were looking for the wrong kind of evidence. Then researchers searched through the rock, image by image, and found the beaks. Not a perfect body, just enough to show that part of the food web had been hiding in plain sight. That is why Nanaimoteuthis matters. It reminds us that the fossil record is not the ancient world. It is only what survived from it. And sometimes, an animal that survives as almost nothing may have been one of the animals that mattered most.